Hello everyone. For this tutorial video, I like to talk about the most abstract type of heat transfer, radiation, as well as explain that it works for every single object because it does not actually involve any matter to work, which is not true for conduction or convection. In particular, radiation involves something known as electromagnetic waves, which is a broad spectrum of different types of waves such as light, radio waves, gamma radiation, and so on. But generally, heat radiation is limited to a specific type, which are called the infrared waves. And they are called that because they are literally beneath light waves on the electromagnetic spectrum chart. And red is the lowest color on the light part of the electromagnetic spectrum. You can feel definite evidence that radiation is caused by electromagnetic waves and not by a flow of matter because you feel warm from the sun, even though the sun physically exists in outer space where there is no matter. Or at least there is a large emptiness where there is no matter, although there is some matter, such as planets and stuff like that. But by and large, in outer space, it is a vacuum with no matter in it. And cooking ovens and microwaves also radiate heat, as well as furnaces. Although those are only obvious and common examples, literally everything radiates. In general, the energy of an electromagnetic wave depends on the wavelength of it, which in the visible part of the spectrum you see as a change in color. And the general formula for it is the smaller the wavelength, the larger the energy. This explains why, somewhat, objects glow red hot when they get warm, like coals in a fire. Because from looking at the chart, we can see red has a shorter wavelength than the other colors. And we can also see that the heat part of the spectrum, infrared, has an even shorter wavelength than red, as given in its title. So it should be hotter because it has more energy. Just like color itself is very complicated, because there's a nearly infinite variation in exact hues and things like that. This is exactly as true for the infrared radiation, because even though you may know, as a general rule, black is the best absorber, and white is the worst absorber, so you use that fact when you wear clothes. For any color besides those two specifically, there's no neat way to predict exactly how good of a radiator it is. So it requires case-by-case analysis, exactly like the problem with thermal conductivity. And we can get an exact formula for radiation as Q over T equals emissivity constant, written with lowercase e, times the Stefan-Boltzmann constant, written with a Greek letter sigma, times the surface area of the radiating body, times the absolute temperature rather than a temperature difference like with conduction, to the fourth power, where absolute temperature means temperature measured in kelvins specifically. So this formula explains that the better something radiates, the more heat transfer it will do, which is obvious, and the larger the surface of the radiating object, the quicker it will radiate as well, which may seem more arbitrary and not as intuitive. But you will notice this is true in real-life experience if you ever moved a group of coals apart from each other, and noticed how you felt hotter afterward. And then we have absolute temperature to the fourth power because we remember the Kelvin scale is colder than the Celsius or Fahrenheit scale. So this helps explain why the temperature must be raised to such a dramatic amount in order to cause a noticeable heat effect. Now that I've explained how radiation works, I can explain the most sophisticated types of heat transfer concepts, which is thermodynamics, and is the science of relating heat transfer to other types of energy, such as mechanical work, and predicting how systems will behave using these laws. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.